Okay, we know the problem. Hannah knows there are 6 orange sweets in the bag as well as some yellow sweets. She removes a sweet and it's orange. She eats it. She removes a second sweet and it's also orange. She eats it too. The probability of taking 2 orange sweets consecutively is 1/3. So we're told that. Then the nightmare comes. Prove that n squared minus n minus 90 equals 0. There's the bag. We know there are 6 orange sweets in the bag, and we know there are some yellow ones. We don't know how many there are, but we do know that when she takes 1 sweet out and then takes out 2 sweets, the probability of that equals 1/3. How about that? Let's back up a bit. Heads, heads, heads. So backing up, we know if we throw a coin, probability of throwing a head is a half, probability of throwing a tail is a half. If we throw again, get a head, we know it's a half, tail, we know it's a half, head, we know it's a half, tail, we know it's a half. So the probability of head equals a half times is a quarter. Head, tail is the same. Tail, head, same. Tail, tail, same. We can add these and that would be a half. So getting 2 heads is a quarter, 2 tails is a quarter, but a head and a tail or a tail and a head is a half. Back to Hannah's problem. Let's for a minute assume we do know how many there are. We know there are 6 orange, and let's assume that there are 6 yellow. We take out 1, it's orange. The probability of that was 6 out of 12, which also equals a half. And now we're going to take out a second one, which we now have 11 in the box. And we only have 5 orange. So the probability of taking the second orange is 5 out of 11. We multiply that by the first probability, and we get 5 out of 22 is the probability of taking 2 oranges. That's not the answer that we were given, so we know that's not it, but that's okay. This was just to illustrate taking 2 orange when we knew we had 6 orange and assume we knew how many were in the box. Okay, so let's finally do it. Here's our bucket. We don't know how many are in there. We do know there are n, and of those n, we know 6 are orange. So the probability of taking 1 orange is 6 divided by n. Probability of taking a second orange is 6 minus 1 over n minus 1. 6 minus 1 equals 5. N minus 1 we can leave it as it is. But probability of getting those 2 in a row is to multiply them. So we have 6 over n times 5 over n minus 1, and we are told in the question that that equals 1 over 3. Multiplying out, we have 6 5s are 30. N times n minus 1 is n squared minus n, and that equals 1 over 3. Multiplying by both sides by 3, we get 90 equals, multiply both sides by n squared minus n, get n squared minus n. So n squared minus n minus 90 equals 0. QED, we've proven it. So we have n squared minus n minus 90 equals 0. That's probably taking out 2 oranges out of selection. So we have a basic quadratic which we just need to solve. What 2 numbers multiply to make minus 90 and add to make minus 1? Well, if you think about it for a second, 9 and 10 make 90. We just need to add them to make minus 1 and multiply to make minus 90, so one of them has to be negative. That's this one, so it's 9 times minus 10. So n equals 10 or minus 9. Real world situation, so not minus 9, so n equals 10, which is why I put in 4 yellow counters. Let's just check it back. Probability of taking an orange the first time is 6 out of, we now know n equals 10, and now after we've taken one out we've got 5 left, and we've got 9 left, and that equals 30 divided by 90, and that equals 1 over 3, and that's where we started. Job done.